Welcome to solverfy.
Okay, so we have a conceptual question here, that is why polarized light is possible, or is a part of nature, and why polarized sound is not. Okay, so for this we have to understand what is a wave, and what kind of waves we have. Okay, so a wave is a perturbation of the media. Okay, and you probably know this, but we have two types of waves. Okay, the first one, that is this transverse wave. Okay, it's the kind of wave that the direction of oscillation is perpendicular to the direction of motion of the wave. Okay, what does this mean? Okay, imagine this is a string. Okay, and you have your hand and you're pulling it up and down. Okay, and now fix on a single point. Okay, like this on this string you have. And what happens to this point? If you see, you start the perturbation here, and it comes through all the points of the of the string. Okay, but so the perturbation travels to the horizontal. Okay, but every single one of these, let's say, particles of the string just go up and down. Okay, up and down, up and down. This atom of this string does not move like this. Okay, this just moves up and down. Okay, so what we say is that a transverse wave, the direction of propagation is perpendicular, okay, to the motion. So what I said before were explained. Okay, and on a longitudinal wave, the direction of propagation, okay, it's like you have a spring and you have your hand, but instead of moving up and down, you move to the front and back. Okay, so you're applying some pressure to the string, and so it compress and decompress. No, so like here's compression, decompression. So you see, the direction of propagation is, as I said, also to the right. But if you look at one of the particles or atoms of this thing, you see that it comes like to the right and to the left. Okay, so it displaces like this. Okay, to the right and to the left. It doesn't go up and down. So the direction of propagation and the direction of motion, it's parallel. Okay, it's the same. Okay, now what is polarization? Polarization is a property, okay, that it's only of transverse waves. That now imagine that we have this string, but in three dimensions. Okay, so you can see we can not longer have just this vertical movement like we had before. We can also have it like horizontal. Okay, that is like kind of like the electric magnetic field, or we can just have it like any angle we want. You see, this is like I try to imagine a 45 angle degree. Okay, so we can let's say like just rotate this let's say string. Okay, and that is polarization. Okay, it's a property that only applies to transverse waves. Why? Because I cannot do the same to this kind of wave. If you see, if you think about this spring. Okay, it does not matter in what how you rotate this. Okay, it will always look like this. Like here is compression, here is not, here is compression, here is not, and you can just rotate it any way you want, and it will always be the same. Okay, so that is why polarization, it's only for transverse wave. Does not make sense to say it for longitudinal waves. Okay, so when we go back to the question, so why polarized light is a part of nature but polarized sound is not? Because light, okay, is a transverse wave. Okay, it can be polarized, but sound is a longitudinal wave. Okay, so For sound, something like this happens, but with the air molecules and your mouth. Okay, so that is why there cannot be polarized sound.